Hi guys, today I'll be trying leetcode 226, which is inverting a binary tree. So the problem is quite simple. Given the root of a tree, you have to invert the tree and return the root value. So let's look at the examples given to us. It'll be easier for us to understand. So basically the problem is a very simple example of depth first search, which is a popular algorithm. So we'll try and implement that also somewhere. So example one, I can see that we are swapping the left and the right subtrees basically, because a right subtree in this case would be 7, which has two children 6 and 9, which shift the left subtree, and the left subtree in this case is 2 with its children 1 to the left and 3 to the right. That's going to the right subtree, and our input is root of 4, and then you go to the left 2, then 7, then 1, then 3, then 6, then 9, and our output would be 4 7 2. Yep, 4 7 2. Then you have all the other children. So you have 9 6 from the left to the right. 9 6 3 1. That's our output. Similarly, if we have a second example, we're swapping 3 and 1. So our root in the first case would be 2 1 3, and the output would be 2 3 1, because we're swapping the left and the right. And obviously our base case would be when we have nothing. So when our root is nothing, our output is nothing again. So it seems like a simple enough problem. I'll have two approaches to it, and let's see which one kind of works better, because I think the second approach is much more efficient in terms of like algorithmic thinking. So first solution is quite simple. We take our base case, which is inspired from this example. So if we don't have an if we don't have a root which contains elements inside of it, so we have this, we return nothing, right? Because we have left as none and right as none as initial values, so we return none. Okay, and if that's not the case, we'll then swap. So we need to have a temporary variable which takes root dot left, and we assign root dot left to root dot right. Yeah, and yeah, root dot right. Okay. And once that's done, uh we can okay we in this case we have to kind of recursively call the function again. So we do self dot invert tree root on the left of the tree, and similarly on the right, and we turn, okay, that's, yeah, root. We return root in this case. So that should be fine. I'll try and run this and see if it works. Last time there was a problem with runtime, but yeah, in this case it works. It's accepted. We'll try one more solution, but yeah, this works in this case. So we'll comment this out for now and move this to the bottom, and I'll try another solution which kind of does not use a temporary variable, so that it would be easier to understand in this case. So we start again with our base case. If not root, if we return, and we set our root left, root right to the self invert. We're calling the function right, so we do that. Tree on. Okay, so we have root of left here. We want the swaps to be done to the right, so we do that. Eventually the change is made on root of left, and we do it again here. Okay, and when that's done, all we have to do is do this. As simple as that. I think it should work. Let's see if it does. We run this, and yep, it's accepted. And if we try and submit this, that should also be fine, which works in 32 milliseconds. It's quite nice, I think. and we tried both solutions. This one basically, what happens is that we replace directly root dot left and root dot right, and the change occurs in root itself. We return root. Um, but here we had taken a temporary variable and done it, so that should not be an issue. But yeah, I mean, this is much more efficient in terms of like thinking. It's a single line basically. So yeah, that was my take on this. So thank you so much, and I'll see you in the next one. Bye bye.